Hi, welcome to our channel. In today's video, we are going to learn about simplex method. First of all, let's see what is meant by simplex method. Here there is a definition about simplex method, which means by seeing this we can understand what is simplex method. And in the same way, in today's video we are continuing to the simplex method algorithm in which we will learn about how to solve a simplex problem. Let's go to the video. It is meant by simplex method. Here there is a definition about simplex method. I'll just explain the simplex method and you can get this PDF from the link given in the description box. Okay, so please follow the link in order to get this PDF. Now, what is meant by simplex method? It is an iterative process for solving LPP in a finite number of steps. It provides an algorithm which consists of moving from one vertex of the region of feasible solution to another in such a manner that value of the objective function at the succeeding vertex is less or more, as the case may be, than at the previous vertex. This procedure is repeated, and since the number of vertices is finite, the method leads to an optimal vertex in a finite number of steps or indicates the existence of unbounded solution. Normally, simplex method means it is an iterative procedure, which means it takes a step by step, step after step, in order to up to getting the finite solution. Up to getting an finite solution, the steps will be repeated by following some algorithm. Now let's see a overlook how to solve a simplex algorithm, how to solve a simplex problem. So let's see the simplex algorithm. What is meant by simplex algorithm? Here, simplex algorithm means further solution of any LPP by simplex algorithm. The existence of an initial basic feasible solution is always assumed. In order to solve an LPP by using simplex algorithm, we have to find a basic feasible solution. That is the procedure what we follow in order to get an feasible solution. Now let's see the procedure. In the step 1, we have to check whether the objective function is maximized or minimized. In the first step, we have to select whether the given function is maximized or minimized. If it is maximized, if the sum is maximized, then no problem, we will continue to the second step. If not, if the sum is minimized, then we have to convert the problem into maximization by following this method, where we have to multiply the minimum, where the objective function is minimum, we have to multiply with minus, then the minimum function will be converted into maximum function. Then we can go to step 2. In the step 2, let's see what is the procedure in the step 2. In the step 2, we have to check whether all bi, here bi means the solution, which means the constraints will have. If here I am writing about the constraints, x1 plus 2 is less than or equals to 1. If this is known as bi. If it is like this, if it is in positive, then no problem, we can continue to step 3. If there is a negative symbol here, if x1 plus x2 is less than minus 1, then we have to multiply of full equation with minus, then only we can go to step 3. That is the what we have in step 2. Check all other bi are positive. If any bi is negative, then multiply the equation of the constraint by minus 1. Then we will go to the step 3. Now let's see what we are having in the step. Express the problem in standard form by introducing slack or surplus variables to convert the inequality constraints into equations. Here we have to convert the given inequalities into equations. This will be explained in the sum, how to convert the inequalities into equations. Okay, now let's see the fourth step in the simplex problem. In the step 4, we will obtain an initial basic feasible solution to the problem in the form of xb is equals to b inverse b and put it in the first column of the simplex table from the initial simplex table as given below. In the step 4, we will build up a simple basic simplex table, which means how the table will be means like this. Cj, here Cj means the objective variables will be written here, and this is the basic constants, and this is the basic terms. Xb means basic solution, x1 x2 x3 x4, these are the constraints what we are having. This all will be clear while doing the sum. So just let us know what to do in the sum. Okay, now let's go into the step 5. In step 5, we will compute by the formula j minus cj by using relative zj minus cj is equals to cb into aj minus cj, and we have to examine the sign of zj minus cj. We can call this as zj minus cj or cj minus zj. Now we will examine over the signs. If zj minus cj or if zj minus cj is greater than or equals to 0, then the initial basic feasible solution is an optimum. If it is less than, if at least zj minus cj is greater than or 0, then we will go to the step 6. Step 6, we will see how to solve we have to do how find out the entering variable. We have to find out the entering variable here. We find out the entering variable. How we find out the entering variable means, if there are more than one negative zj minus cj, if there is one negative in zj minus cj, then we will find out the entering column and leaving variable, entering variable and leaving variable. Okay, this is the step what we follow. If there are more than one variables having the same most negative zj minus cj, then any one of them can be selected arbitrarily as the entering variable. Now in the step 7, we will find out the leaving variable. How we find out the leaving variable means, we will find out the ratios of xbi means solution and akr means key element. We will find out the ratio, and the minimum ratio value will be the leaving variable. Now let's see the step 8. From a new basis, by dropping the leaving variable and introducing the entering variable, we will find out a new element. In step 5, we will find out the new element, and we will repeat the process, and the formula for new element is old element minus product of elements in key row and column by key element. This is the formula how to find out the new element. Now we will repeat the steps until getting the basic feasible solution. Here basic feasible solution means we have to get zj minus cj must be greater than or equals to 0, then the solution is basic. Okay, this is the algorithm of simplex method. First of all, we have to go through the algorithm in order to solve a simplex problem, and in the same way we will go to the finding the step. After finding the new element, we will go to step 5. From step 5, the process will be repeated until we are getting the basic feasible solution zj minus cj must be greater than or equals to 0. This is all about simplex algorithm and simplex problem introduction. For more videos, please do subscribe our channel and tap the bell icon in order to get the notification immediately and you don't miss the video. Thank you.